Initial position of a body is 4 meter from some reference, okay? And let's assume that this reference is a ground and this height is 4 meter. So this is the initial position of the object. So if you will throw this object with some velocity, and according to this graph, this velocity is 8 meter per second at the time t is equals to 0, this velocity is maximum. It means that it's a positive velocity, means that we have thrown this object upward. So with how much speed? That is positive 8 meter per second. So since it is a free fall motion, what will happen? This object will go up. Give me a second. It's not a free fall motion. Its acceleration is equals to negative 2 meter per second square, but that is actually a uniformly accelerated motion. So anyways, what will happen? This object will move up. It will cover more and more position. Its position will increase, but you see from the graph that its velocity is decreasing and its acceleration is negative. At some point it will stop and then it will return from that point. So we have to find out the position at the 6 seconds. So I have separately drawn this graph, and at 6 seconds you can see that its velocity is negative 4 meter per second. That clearly shows us that this object is moving vertically downward, or it is moving leftward if this motion is on x-axis. Okay, anyways, so how can you find out the position? We know that if this is a velocity time graph, then the area under this graph will be equals to displacement covered. Okay, so we will calculate the total area under this graph. This will give us the positive displacement. So 1 over 2 into 4 second and into 8 meter per second will give us 16 meters, which means that this object has covered the maximum, I mean, like at this point. For example, if it reached at this point, so then this total displacement from this point is 16 meter. But this is a displacement till time t is equals to 4 second, and this is the time t is equal to 0 second. Okay, now we are going to calculate this area under this graph, which will be obviously a negative value because it shows us 1 over 2 into 4 second minus 6 second, which is 2 second, into negative 4 meter per second. This is the area under this small triangle, which is negative 4 meters. Okay, now what does it mean? This negative 4 meter means that at this point t is equal to 4 seconds, this object turned downward. Okay, and now it is somewhere, let's say at this point. So it covered displacement of negative 4 meters downward. Okay, so which means that now how much is the displacement remaining from this point? So 16 minus 4 meter is 12 meter. Okay, I hope you understand that this is now only 12 meter from this position. Okay, but from the reference, what was our reference position? Our reference position was ground. So what is the total displacement from ground? That is 16 meter, because this was a question. So according to this, the right answer is option B.